Welcome to Medical and Engineering Entrance Examination, Physics Questions and Answers. Electrostatics Unit 1 we are continuing, and today we see capacitance. Questions based on capacity, and this is ME-5, class number 5, capacitance. Medical and Engineering Entrance. And here is the first question. Which one of the following statements regarding the capacitance of a parallel condenser is wrong? You see, the question is wrong. Which one of the following statements regarding the capacitance of a parallel plate capacitor is wrong? ഒരു പാരലൽ പ്ലേറ്റ് കപ്പാസിറ്ററിനെ സംബന്ധിച്ച് ഇനി പറയുന്ന സ്റ്റേറ്റ്മെൻറ്റുകളിൽ ഏതാണ് തെറ്റായിട്ടുള്ളത്? ശരിയായിട്ടുള്ളതല്ല, ഏതാണ് തെറ്റായിട്ടുള്ളത്? അപ്പം മൂന്നെണ്ണം ശരിയായിരിക്കും. Which one of the following statements regarding the capacitance of a parallel plate condenser is wrong? A. Capacitance of a parallel plate condenser varies linearly with the common area of the plate. Number 2. Capacitance of a parallel plate condenser varies inversely with the separation of the plates. C. The capacitance of a parallel plate condenser varies with the material between the plates. D. Capacitance of a parallel plate condenser varies with the material of the plates. അപ്പോൾ കപ്പാസിറ്റിയുടെ ഇക്വേഷൻ ഓർത്താൽ മതി. You remember the expression for capacity of a parallel plate capacitor. C is equal to epsilon 0 A by D or epsilon R A by D. For a parallel plate capacitor with a dielectric medium of constant epsilon R, the capacity is given by C is epsilon R A by D. So it depends upon separation, it depends upon area, and it depends upon the material. So the wrong answer is D, last one. Capacitance of a parallel plate condenser varies with the material of the plates. That is wrong. Material has no role regarding capacity. Answer D. Answer D is written here, 1D and 2 also D. We are going to read 2. The capacitance of a parallel plate condenser does not depend upon area of the plates, medium between the plates, distance between the plates, material of the plates. The same question in a different way. Answer is D, 2D. Next question. In a charged capacitor, the energy is stored in the field between the plates, the positive charges, the negative charges, none of the above. In a charged capacitor, the energy is stored in field between the plates, the positive charges, the negative charges, none of the above. Answer of 3. 3 we can see here. 3A. The energy is stored in the electric field between the plates. 3A. And the fourth question. Which of the following relations is correct? V is equal to Q by C, C is equal to QB, B is equal to C into Q, Q is equal to B by C. You remember, the relation is Q is equal to CV. The relation is Q is equal to CV, and that holds good in A. Answer for A. When we cross multiply, we get Q is CV. Q is equal to CV is the basic equation for charge and capacity and potential. So the first relation is correct, from which we can write Q is equal to CV. Number 5. Farad is the unit of A, self-inductance, B, capacitance, C, mutual inductance, D, conductance of the electrolyte. The answer is capacitance. Farad is the unit of capacitance. Remember, Farad is the unit of capacitance. Next question. Two insulated charged pairs of ready R1 and R2 having charges Q1 and Q2 respectively are connected to each other. There is no change in the energy of the system, and increase the energy of the system, always decrease the energy of the system. D, a decrease in the energy of the system unless Q1 R1 equal to Q1 R2 equal to Q2 R1. You look here, two insulated charged pairs of radii R1 and R2 having charges Q1 and Q2 respectively are connected to each other. രണ്ട് കപ്പാസിറ്റി ഉണ്ട്, ആ രണ്ട് സ്പേഴ്സ് ഉണ്ട്, ചാർജ് Q1 Q2 ആണ്, അവിടെ റേഡിയൈ R1 R2 ആണ്. അവ ഒരുമിച്ച് പിടിപ്പിച്ചാൽ എന്താണ് സംഭവിക്കുക? നോ ചേഞ്ച് ഇൻ ദി energy of the system or increase in the energy of the system, always a decrease in the energy of system, decrease in energy of the system unless Q1 R2 is Q2 R1. We can see the answer 6 answer D. There is a decrease in energy of the system unless Q1 by Q2 is equal to R1 by R2. അപ്പോൾ ഡിക്രീസ് ഇൻ എനർജിയാണ് ഉണ്ടാകുന്നത്. അപ്പോൾ ഡിക്രീസ് ഇൻ എനർജി ഉണ്ടാകണമെങ്കിൽ അതിന് കണ്ടീഷനുണ്ട്. ഈ Q1 R1 Q2 R2 അല്ലെങ്കിൽ അതൊഴിച്ച് unless a decrease in energy of the system. That is the answer. അതായത് കപ്പാസിറ്റിയാണ്, ഈ സ്പിയർ രണ്ടും കപ്പാസിറ്റികളാണ്, കട്ടർ സ്പേസാണ്. അപ്പോൾ ചാർജ് ചെയ്യുമ്പോൾ ലോസ് ഓഫ് എനർജി ഉണ്ടാകും. ആ ലോസ് ഓഫ് എനർജി ഉണ്ടാകുന്നത് എല്ലാ കേസിലുമാണ് ഈ ഒരു കണ്ടീഷൻ ഒഴിച്ച്, ഈ ലാസ്റ്റ് കണ്ടീഷൻ ഒഴിച്ച് ബാക്കി എല്ലാ കേസിലും ലോസ് ഓഫ് എനർജി ഉണ്ടാകും. ആൻസർ ഈസ് ഡി. നമ്പർ 7. The capacitance of a parallel plate capacitor, capacitor is given by A, Q is equal to CV, B, C is equal to QA by 9 into 10 raised to 9 4 pi D, C, KD by 9 into 10 raised to 9 4 pi A, D, C, A is A by 9 into 10 raised to 9 4 pi KD. And here we know the capacity is equal to capacity C is equal to Q by V. In that manner we write capacity C is Q by V. And for a parallel plate capacitor, C is epsilon 0 epsilon R A by D. Epsilon 0 epsilon R A by D. Whatever be the constants, 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. That is by this factor is coming. And in a different system, there may occur 4 pi. What we have to note here is, remember the relation, epsilon 0, epsilon R, A by D. That you remember. Epsilon 0, epsilon R, A by D. 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. So from which we can say epsilon R. Epsilon R here we write as K. Epsilon R is K. So epsilon 0, epsilon R, A by D. K or epsilon R will come in the numerator, A will come in the numerator, and D will come in the denominator. That relation is B. 7, answer B. ഇവിടെ ആൻസർ നമ്മൾ ചെക്ക് ചെയ്ത് നോക്കുക. കപ്പാസിറ്റർ ഇക്വേഷനെ ഒരു പാരലൽ പ്ലേറ്റ് കപ്പാസിറ്ററിൻ്റെ ഇക്വേഷൻ എപ്സിലോൺ 0 എപ്സിലോൺ ആർ എ ബൈ ഡി ആണ്. എപ്സിലോൺ ആറിനെ നിങ്ങൾ കെ എന്ന് വിചാരിക്കുക. പിന്നെ എപ്സിലോൺ 0 എന്താണ്? 1 by 4 pi epsilon 0 9 into 10 raised to 9 ആണ്. 1 by epsilon 0 9 into 1 by 4 pi epsilon 0 9 into 10 raised to 9 ആണ്. അപ്പോൾ എപ്സിലോൺ 0 കാണുമ്പോൾ 1 by 4 pi into 9 into 10 raised to 9 അതാണ് എഴുതിയിരിക്കുന്നത് ഇവിടെ. അപ്പം അത് ഒഴിവാക്കിയിട്ട് നോക്കിയാലും മതി. എപ്സിലോൺ 0 എപ്സിലോൺ ആർ എ ബൈ ഡി എന്നാണ്. എ മുകളിൽ വരണം, എപ്സിലോൺ ആർ കെ മുകളിൽ വരണം, ഡി താഴെ വരണം. അങ്ങനെ വരുന്ന ഇക്വേഷൻ ബി ആണ്. ബി ആണ് ശരിയായിട്ടുള്ള ഉത്തരം. Number 8. A capacitor works in AC circuits, DC circuits, both the circuits, neither in AC nor in DC. Uttaram C ആണ്. It will work in both AC and DC circuits. When DC is connected, capacitor plate is charged. When AC is connected, it will conduct. It will conduct with an impedance 1 by C omega. Question number 9. Variable parallel plate capacitor and an electroscope are connected in parallel to a battery. A variable parallel plate capacitor and an electroscope are connected in parallel to a circuit. the reading of the electroscope would be decreased by, you look here, a variable parallel plate capacitor, a variable parallel plate capacitor and an electroscope are connected in parallel to a battery. The reading of the electroscope would be decreased by increasing the area of overlap of the plates, placing a block of paraffin wax between the plates, decreasing the distance between the plates, decreasing the battery potential. Then state if A, only 1, 2 and 3 are correct. B, only 1 and 3 are correct. Only 2 and 4 are correct. Only 4 is correct. The answer is D. You look here, the answer is 9D. So what is 9D? A hint is given here. You look here, a hint. The electroscope is a charge measuring instrument. ഇലക്ട്രോസ്കോപ്പ് ഒരു ചാർജ് അളക്കുന്ന ഉപകരണമാണ്, ചാർജ് measuring device. We know Q is CV. So reading of the electroscope will decrease if either C or V or both. And V, both C and V are decreased. In the given first three cases, the capacitance increases because C is equal to epsilon R, epsilon 0 A by D, or K epsilon 0 A by D. In the fourth case, the battery potential is decreased and hence electroscope reading will also be decreased. So the fourth case is the correct one. Next one, a parallel plate capacitor is charged and the charging battery is then disconnected. Then the charge on the capacitor will remain constant. If the plates of the capacitor are moved further apart by means of insulating handles, A, the charge on the capacitor increases, the voltage across the plate increases, the capacitance increases, the electrostatic energy stored in the capacitor increases. A parallel plate capacitor is charged and the charging battery is then disconnected. If the plates of the capacitor are moved further apart by means of insulating handles, ഇപ്പോൾ ഒരു കപ്പാസിറ്റർ ചാർജ് ചെയ്യും, എന്നിട്ട് ബാറ്ററി ഡിസ്കണക്ട് ചെയ്യും, പ്ലേറ്റ്സ് നമ്മൾ അകലത്തിലേക്ക് മാറ്റും, ഇൻസുലേറ്റിംഗ് ഹാൻഡിൽ ഉപയോഗിച്ചാണ് മാറ്റുന്നത്, ചാർജ് അങ്ങോട്ട് ചെല്ലാൻ സാധ്യതയില്ലാത്ത രീതിയിൽ. അപ്പോൾ എന്ത് സംഭവിക്കും? ചാർജ് ഓൺ ദി കപ്പാസിറ്റർ ഇൻക്രീസസ്, ഇത് വോൾട്ടേജ് അക്രോസ് ദി പ്ലേറ്റ് ഇൻക്രീസസ്, ഇത് capacitance increases, the electrostatic energy stored in the capacitor increases. Answer B and D. You look here, when the battery is disconnected, the charge on the plates remains the same. The disconnect ചെയ്യുമ്പോൾ charge same ആയിരിക്കും. Now plates are moved further, that is separation D increases, hence the capacity decreases, C proportional 1 by D. Now the voltage between the plates is V is equal to Q by C, and also U is equal to Q square by 2C increases because C decreases. So answer B and D. With this, the class number 5, ME-5 is over. We continue our class. Thank you very much.